Hello everyone. In iQuanta series, let's discuss few problems based on geometry, numbers and PNC from CAT 2022 slot 2. First question is based on geometry. It says regular polygons A and B have number of sides in the ratio 1:2 and interior angles in the ratio 3:4. Then the number of sides of B equals. So what do we know? Sum of all interior angles in any polygon is equal to n minus 2 into 180 degrees, where n is equal to number of sides. So if it's a regular polygon, we can say each interior angle will be equal to n minus 2 into 180 divided by n. Now in the question, it says sides are in the ratio of 1:2. So let's take those sides as n and 2n, and ratio of their interior angles is 3:4. So for the first polygon, each interior angle will be equal to 180 into n minus 2 into 180 upon n, and second interior angle, each interior angle will be 2n minus 2 into 180 upon 2n, and this should be in the ratio of 3/4. Now we can cancel out n from here, 180 from here and 180 from here. Now what do we get? We get n minus 2 upon, this is 2 times, so this will go up, and this is 2n minus 2 is equal to 3/4. Or from here, we can say 4 into 2n, it will be 8n minus 16 is equal to, this will become 6n minus 6. Or we can say 2n will be equal to 10, or n is equal to 5. So what do we want? We want number of sides of B. So A is to B, 1:2. So if n is equal to 5, how many sides B will have? B has a total of 10 sides. So that's your answer. Next question is based on triangles. It says in triangle ABC, altitudes AD and B are drawn to the corresponding bases if angle BAC is equal to 45 degree and angle ABC is equal to theta, then AD upon BE equals. So let's draw a triangle. Triangle ABC, A, B and C. Now what do we have? We have drawn two altitudes from A to BC, this is AD, and from B to AC, this is BE. These two are altitudes. Now it's given that angle BAC, this angle is 45 degree, and angle ABC is theta. Using sine rule, what do we know? Can we say using sine rule that AC upon sine theta will be equal to, AC upon sine theta will be equal to BC upon sine 45 degree, or we can say AC upon BC will be equal to sine theta upon sine 45 degree. Now let's say this is our equation 1. Now we need to find AD upon B. What is AD? AD is nothing but altitudes on BC. BE is nothing but altitude on AC. Now if we compare the area of this triangle, what we can say? Area of triangle ABC will be equal to half into AD into BC, and this should also be equal to half into AC into BE, right? So from there, half cancelled out, we can say AD upon BE is equal to AC upon BC. And from equation 1, we know that AC upon BC is equal to sine theta upon sine 45 degree. So AD upon BE will be equal to sine theta upon sine 45 degree, which is 1 by root 2. So this will give us root 2 sine theta. So that's your answer, and answer is option A. Next question is based on triangles. It says the length of each side of an equilateral triangle ABC is 3 centimeter. Let D be a point on BC such that area of triangle ADC is half the area of triangle ABD. Then the length of AD in centimeter. So first let's draw an equilateral triangle ABC, and it's given that D be a point on BC such that, so let's say this is point D, such that the area of triangle ADC is half of triangle ABD. If area of this triangle is X, area of triangle ADC will be X. Now we know that in any triangle, the ratio of area of triangles is equal to the ratio of corresponding bases if vertex is common. So in that case, we can say BD upon DC will be equal to 2 by 1, right? And the whole length is given, which is AC is 3 centimeter, AB is also 3 centimeter, BC is also 3 centimeter. So we can say BD will be 2 centimeter and DC will be 1 centimeter. What else do we know? As it's an equilateral triangle, we can say angle C is equal to 60 degree. So what we can do here, we can use cosine rule. Cosine rule is used when we have three angles, three sides given. We can find out any angle, or any two sides and one angle is given, then we can find out the third angle. So the basic property of cosine rule is something like this. Side lengths A, B and C. This is A, B and C. So we can say cos A will be equal to B square plus C square minus A square upon 2BC. This is what we can use here. How? We know the length of AD. This is what we need to find. We know the length of CD. We know the length of AC. We know the angle 60. So using this, we can find out AD. What we can do here is sine or cos C will be equal to 3 square plus 1 square minus x square divided by 2 times 3 into 1. Or what is C? C is nothing but 60 degree, and cos 60 degree is nothing but 1 by 2. So this will be 1 by 2. This is 10 minus x square upon, this will be 6. This is 3 times cancelled out. Or we can say 3 is equal to 10 minus x square, or x square will be equal to 7, or x is equal to root 7 centimeter, which is our option D. But apart from that, if you don't know the cosine rule, you can also solve it using some construction. Like if I draw a perpendicular from A to BC, say this point is E. In that case, ED will become 0.5. ED will become 0.5. Why 0.5? BC is 3 centimeter. In that case, E will be the midpoint because of equilateral triangle. Median and altitude are same line. So EC will become 1.5. DC is 1 centimeter. ED will become 0.5. And this length AE is nothing but height of this equilateral triangle, which is root 3 by 2 into side length. It will be 3 root 3 upon 2. Now we know the length of AE. We know the length of ED, which is 0.5. We can use the Pythagoras theorem to find the length of AD, which is again, if you solve, you will get root 7. Next question is based on numbers. It says for some natural number n, assume that 15,000 factorial is divisible by factorial of n factorial. The largest possible value of n is. So for that, if we talk about option A, this will be 5 factorial of factorial. So this will become 120 factorial, which is definitely dividing 15,000 factorial. If you talk about 7 factorial, what is 7 factorial? 7 into 720, which is 5040 factorial. Again, this value is also dividing 15,000. 4 factorial is lesser than 7 factorial. 6 factorial is also lesser than 7 factorial. So we don't need to check them. So in that case, the largest number is 7. You can also start with checking from largest number, which is 7. 7 factorial is 5040. So definitely 15,000 factorial divided by 5040 will give us some positive integer, right? So hence this value is divisible by 7 factorial. Our answer is option B. Next question is a very interesting question based on permutation and combination, or it just uses fundamental rule of counting. It says the number of integers greater than 2000 that can be formed with the digits 0, 1, 2, 3, 4, 5 using each digit at most once. Now if you check, there are 6 different digits given. We are talking about numbers greater than 2000. So those numbers could be 4-digit number or 5-digit number or 6-digit number. So let's see how many 4-digit numbers are possible, how many 5-digit numbers are possible, and how many 6-digit numbers are possible. So for the 4-digit number, 1, 2, 3, 4, what we can take? Let's start with 2 first. Now out of these remaining 5 digits, I can fill this place by 5 ways. Any value 0, 1, 3, 4, 5. This place then will be filled with 4 digits, and this place can be filled with 3 digits. 5 into 4, 20. This will be 60 different numbers. Then comes another case where this value is not 2. This could be either 3 or 4 or 5. So this place can be filled with 3 ways. Now out of 6 digits, we have taken 1 digit for sure. So the remaining place can be filled with 5 ways, then 4 ways, and then 3 ways. So total number of such integers will be 15 into 12, which is 180. So how many 4 digits numbers are possible? 240 such numbers are possible. Now if we talk about 5 digits numbers, 1, 2, 3, 4, 5. So only 0 cannot be placed here. Rest of the 5 digits can be placed here in 5 different ways, and then 4, then not 4 actually. Now as we have used 1 to 5, now we are still left with 5 digits, so we can use any of the 5 digits here, then 4, then 3, and then 2. So this becomes a total of 600 such integers. In case of 6 digits, 1, 2, 3, 4, 5, 6, 0 cannot be placed here. So again, this place can be filled with 5 different ways. Second place, now we can fill 0 here. 1 digit we have used here. Now we are left with 5 digits that can be filled, and so on. And this is once again 600 integers. So a total number of such integers that we get is 240 plus 600 plus 600, which is equal to 1440. So what's your answer? Answer is option A. So with that, we are done with CAT 2022 slot 2 all the problems. Okay. You can watch more such videos by going to iQA by iQuanta playlist on YouTube channel and check out those videos. Thank you.